here's a complete guide to civil estimating. We're going to cover everything from how to read drawings, perform quantity takeoffs, to determine the type of plant and equipment to use to apply productivity rates, and ultimately calculate costs. Civil estimating is ultimately about volumes. You're working out the cost and the most effective way to move large amounts of dirt from one place to another. It's fundamentally a logistics puzzle. Where does the excavated material go? Can you reuse it? And what compaction ratio should you be using? So in this video, I'm going to show you the exact step-by-step process you can use to calculate the costs of civil construction works. So because we all know theory isn't really that useful, it's much better to just do an example. So as we go through the video, I'm going to be working through this example, which is the construction of a berm along here, and then the excavation of a sediment basin. I just literally Googled civil construction drawings and got this project. It seems pretty interesting. It covers all the key activities, so clearing and grubbing, placement of fill for the berm, compaction, excavation of the basement. I'm not talking about concrete and structural work because I've done that in a separate video and I think it is a separate topic. And I also use Bluebeam for my quantity takeoffs. Look, I think all the quantity takeoff softwares are pretty much the same. My sort of approach to thinking about it is I just pick one tool and then stick with it because you learn the ins and outs of how it operates. If you use PlanSwift or something different, the principles are going to be exactly the same. And then I'll actually be putting together the estimate in my estimating software Operum. The feature of building estimates is completely free, so you can check it out and try it and see if you like it. But again, if you prefer to use Excel or use other softwares, again, the principles are going to be the exact same. We have a resource library with all our different rates, productivities, and costs for different materials and plants. And then we're going to be putting together a structured estimate based on the bill of quantities we extract, and then calculating the cost of each activities. The principles are all exactly the same. Now, I say this in every single video I do, but when you're pricing a project, the first thing you do is you always look at the scope of works in the contract before you start tearing through the drawings. Now, the reason I always say this is because the scope of works tells you what you're actually pricing. The drawings are what is getting built. They're the superset of the project. The client might be doing some stuff. They might expect you to do other stuff. The scope of works is what tells you the specifics of what you actually have to price. Are you removing the vegetation from site? Do they have fill material that you can reuse? All this stuff needs to be, all this stuff should be in the scope of work. So the scope of works is the lens through which you look at the drawings. The drawings help you understand what's being built, calculate specific measurements and quantities, determine the construction methodologies, but fundamentally what is in or out of your price is the scope of works. So this isn't a real scope of works, this is just one I made up for the project, but it gives you a general overview of the work. So we're the contractor, we need to provide all labour, plant, materials, supervision and temporary works necessary to complete the earthworks described in the scope of works in accordance with the bill of quantities and the project drawings. Works are to be completed in a safe, efficient manner and in accordance with relevant environmental and safety requirements. Every scope of works has that exact same thing, nothing new there. Clearing, so then it's given us more of a detailed breakdown of the different activities. So clearing and grubbing, we're supposed to carry out the clearing and grubbing, removal of vegetation. So there'll be some costs associated with taking this off site, the stumps, stripping of the topsoil, stockpiling or disposal of cleared material in accordance with the BOQ requirements. Again, this is where you want to look at these contradictions between the different documents when you're doing it. You have to look what the BOQ actually says. Then we've got the actual, so if you imagine that would be the clearing and grubbing for this firm. So we should get I said you start with the scope of works, but now I'm taking back what I said. You want to get a brief overview of what we're building. So I've looked at the drawings. I know that this is a berm and this is a sediment basin that's 2 feet deep. The berm, they've given a cross section. So if you can imagine, it's some compacted fill sitting on top of that. So if you imagine that's just grass there before, we have to excavate and backfill that. So strip the topsoil to 2 feet. And then the sediment basin I thought was interesting because the cross section wasn't in the drawings, but there was actually these notes. But you can imagine that would be like a 1 in 4 batter going down to 600 mil deep. And that would be the surface area we have to remove. So clearing and grubbing, if we were going to work out the quantity of work from this, it would be the width of the batter and the width of the batter which we would clear and grub, and the area of that sedimentation basin. The next item in the scope of works is the supply and placement of fill for this berm. So again, that is importing all the material and compacting it to construct this golf cart road. So that would be the costs of importing fill, the labor and plants to compact it and roll it. And then the final element of this scope is the excavation for the sedimentation basin. So excavation of material to the required depth and footprint, trimming of the base and sides, handling, stockpiling, or disposal of excavated material, maintaining stable excavation conditions during the work. So that is this basin. There wasn't any cross-section of it, but I would just assume this part is going to be excavated to 2 feet deep, and then you would be able to work out the total volume based on this area here. And I guess you'd use a straight line to determine what's the word I'm looking for? The area or volume. Yeah. Now, they've given some exclusions to the work. They've said dewatering beyond normal surface water management is an exclusion. Import of topsoil for landscaping isn't on us. Lining, fencing, or permanent drainage. Environmental monitoring or testing. So really, the scope of works is really the removal of all the topsoil, the excavation, and the placement of fill. When I look at this, the key questions we would then have is, would be the volume that we're excavating out of here and excavating out of here. Also, number one with the clearing and grubbing would be the volumes of the topsoil and the cost of disposing of the topsoil and the clearing and grubbing. You'd also want to understand, is it just grass, or can you do it with an excavator, or would you need to actually cut down a whole lot of trees because that would have a bigger cost associated with it? Then all the material we excavate out of this, how does this match the volume of imported fill we need for our berm? Because fundamentally, the big assumption here would be we can reuse this material to actually construct this compacted fill for the berm. So just recapping step 0, look, read the scope and contract before or as you go through the drawings. Here are some key questions I would think through on a civil package, but really it's so variable per project. These are more or less just prompts to get you thinking about the type of things, but basically you want to have a clear understanding of who's responsible for everything that has an impact on costs. So things like supply responsibility, who's supplying, how are they supplying, are they going to get delivered to site, where is the laydown going to be, can you reuse material, like the example we spoke about for the berm. The scope boundaries, who's responsible for spoil disposal and reuse, who's doing the survey set out, the as-builds, dewatering, temporary works design, any environmental controls. Service relocations are a huge one on any sort of city project. And again, it's not just a service relocation, working around live services, the difference in cost is astronomical. Site conditions, look, I'm not a civil engineer, I'm actually an electrical engineer, but obviously excavating through rock is slower than excavating through fill. Groundwater, these sorts of things. Contaminated material, again, it's a huge cost. Existing services, I already mentioned that. Specifications, what are the compaction requirements? Is it 98%? Is it 95%? Material specs, testing frequencies. Program is a big one for civil works. It's probably not really as big in terms of, I would say, if you get all this other stuff right, because a lot of civil works is volumes and productivities, assuming the task is defined correctly, which really means the site conditions and geotech. I wouldn't say it's like the program duration that is the challenge. I would say it is the continuity of work. If you can, for example, this berm, if you have to break this berm up into 5 separate chunks for whatever reason, this is a bad example because you would get clear access to do this entire thing. But I don't know, say the neighbor makes a noise complaint and you can only have 1 truck going at once, or you can't do it continuously. I don't know, these are terrible examples, but you sort of get my point. The productivity with which you do this entire berm, if you can hit it at once and do the entire thing versus having to break it up into stages. That's probably the big one for civil works, is just understanding the access you have to site and anything that is going to constrain your productivity. And the next would be any sort of payment terms is your price based on the bill of quantities? So are you giving unit rates based on an indicative volume? People often like this because it takes out the quantity risk, but I would think the thing I see is the big risk this introduces is the quantity is much lower than you expected. So what you've priced your productivity on ends up being incorrect. So you should always, if it's any sort of bill of quantities or remeasurable work, you want to specify a minimum quantity in the work. Another one, if there's milestone payments, always try to negotiate progress payments. So in Opera, you can actually use AI to generate this for you. All you do is upload the set of drawings, the scope of works, which I've got open, so it gave me an error. You upload the drawings and the scope of works. It's a big set of drawings, so it's taking a while to upload. And then it'll go through and create a summary of all the key inclusions and exclusions in the package. You have to wait while the text extracted from the document and the PDF is set up correctly, but I'll leave this run and then we can go back to it and I'll just look at all the tender documents, extract the bill of quantities if it's easy to measure. Look, AI isn't perfect for quantity takeoff, so it's an indicative bill of quantities only, but it'll run an analysis and also give you an indication of any key contract terms, any risks, and any RFIs or clarifications you should ask. It takes about, depending on the size of the documents, probably takes 5 to 10 minutes to run. All right, next step is you want to actually build your pricing schedule. So this is how you're going to express your quote to the client. Now, to me, any pricing schedule is simply a breakdown of the scope. So it captures how you're planning on pricing the project. So it captures key activities and it also shows your quantities that you've measured. In this way, you're clearly expressing, in addition to your letter of offer, you're clearly expressing what is in and out of the scope of the project. So based on the scope of works, the most logical breakdown I would create is I would have a section for clearing and grubbing. I would have a section for sediment, basin, excavation. And I would have a section for berm construction. Now, under the clearing and grubbing, actually, I would also put a preliminary cost item. I always put preliminary costs, even if it's not in the client bill of quantities, if they've given you a pricing schedule to fill out. I would always put preliminaries in my pricing schedule. The reason I do this is it makes it much easier to claim and justify extension of time claims if you can clearly show your preliminary costs as a rate per week. So if I go, say for example, we'll talk about this later, but if we've got a 12-week project and I go project management and overheads, if for whatever reason the client is late in giving us access to site, it extends our project duration and we're showing a rate per week for preliminary costs, we can very easily claim an extension of time during construction. I'll pause the video while I do this, but basically now what I'm going to do is just, I'm not going to put in the quantities yet because I'll do that after I've done a quantity takeoff, but I'll just basically go through and enter all, actually I should go at topsoil removal to 200 millimeters deep. So the depth they had on the drawing, I like to put, I don't do imperial metrics. I think 2 feet is like 600 mil. I'm sorry to all the people in the US. I put these in metric because that's how I think. I know that annoys some people, but whatever. 2.2 on some tree removal. So basically, I like to put tons and tons of detail. Actually, I should put 1.2 in my pricing schedule. It's just another tool you can use to communicate to the client, like exactly what is in and out of scope. So yeah, I'm just going to manually put in the rest of these and pause the video while I do it. Okay, so here's what I've got in my pricing schedule. I've got my prelims. So I've got project management overhead for 12 weeks. I don't know how long the project's going to be. We're going to have to work that out later. Got mob and demob. Got topsoil removal to 600 millimeters deep. So that's going to cover all our That's going to recover all, that is going to cover all our topsoil removal and excavation. Then we got, so that's across the berm and the sediment basin. We've got the tree removals, which I'm just going to plug a number in there, but in principle, maybe you'd look at some photos, get a quote if it's going to be a subcontractor. You then got the actual excavation and the sediment basin. We're going to have to work out the quantity of that. The compaction and the surface. In the scope of works, it said, let me just bring that up. In the scope of works, it mentioned that we're responsible for any, where did it say that? Trimming of base and sides of the sediment basin. That's just going to be a meters squared. So that'll be a final roll and trim. And then placement and compaction of the berm. So that's placing this, this is going to be placing all of this fill. Now, the other thing I like to put in my pricing schedules as an indirect or hidden cost. So I'm like so up in the air about the terminology to use for this, but indirect, hidden cost, these are things, costs you're incurring, but you don't want to show in your client pricing schedule. So I always like to have risk. If you're building up a risk cost, you can also just add risk as a percentage for unknown unknowns. And I think it's always good to have, that risk might be like a build-up of hours for an inclement weather allowance, or you could have indirect costs for, I don't know, other hidden costs like, what's a good example? Say bank guarantees and insurances. These are just costs you don't want to show in your client pricing schedule, but you want to build up individually and spread across this. Okay, so I'll put a link in the description to where you can get this checklist, but basically you just have to think through every possible task that could be completed in completing your scope of works. You have to put it in a way that you've got a work breakdown structure to capture all your costs and then communicate scope to the client. So look, I'll put a link in the description. You can go through this checklist if you want. You've got preliminaries and site establishment, demolition and clearing, earthworks and excavation, filling, compaction, cut and fill management. So what does your cut and fill profile look like? Dewatering, temporary works, subsoil drainage, stormwater drainage, open drainage, subgrade and pavements, the actual pavement layers, curb and channel, surfaces, finish, line markings, footpaths, any sort of retaining walls or structures you've got to construct, any utilities and services, underground conduits, erosion and sediment control, fencing and barriers, landscaping and regeneration, and all sorts of overhead. So I won't bore you by going through the whole list. The key principle here is when you're doing your pricing schedule, you just want to really think through every possible thing that could be involved in executing the scope of your project. Make sure you have a crystal clear picture of where it sits, whether it's on you or on your client. Now, my tender analysis in Operam's finished running, but basically what this does is this just goes through all the tender documents. It gives you an executive summary, an overview of the project. So this is earthworks package for blah, 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 measuring, clearing and grubbing, the high level scope. So preliminaries, temporary works, clearing and grubbing, the earthworks, sediment basin, additional drawings. It's gone through and given us a summary of the drawings with, again, this is an AI takeoff, so it's indicative only. The length of the berm is 1,500 linear meters. The sediment basin is 50,000 meters squared. The staging area is 2,000 meters squared. There's 12 cross sections. There's 2 feet deep excavation for the sediment basin. There's concrete flood walls. Some of this other stuff I didn't put in the scope of works because I wanted to make the example clear. Then it's given us an individual summary of each drawing, and we've got a bill of quantities. This is the bill of quantities Operam's come up with, which is a little bit different to my one, where it's got trimming and finishing. Oh, that's actually a better way to express it. I said something about compaction. Placement of fill and controlled layers, supply of approved material. It's broken down the scope more than I did, but this is a very useful thing as well. This is how I think about estimating. It's where you take all the requirements in the tender and turn it into a structured list like this. So every single thing your client is asking you to price, you can then check that it's in your estimate or excluded in your letter of offer. It's given us some suggested RFIs and clarifications, and then the key risk and opportunity. So it said the key risk is the BOQ and measurement rules not provided, unclear instructions in the rates, earthworks quantities missing from the scope, again, they didn't give us a bill of quantities. Scope boundary works. There's interfaces between the earthworks and the hydraulics. And then it's given us some opportunities in there as well. But that's just, I like that way, because I find often what happens is you deal with general contractors, particularly if you're a trade contractor, you deal with general contractors who don't really know anything about earthworks or electrical or whatever you're pricing. So they just send you these huge tender documents that just don't really make any sense. So I like to get a structured summary of the works and think through taking all the requirements and drawings and specifications and making sure they're covered in my estimate or excluded in my letter of offer. All right, once we've got our structure for how we're going to prepare our estimate, the next step, everyone's favorite step, is to do your quantities. So quantities, again, for civil works, the quantity of the work drives the cost. I don't even know why I'm saying this, it's such common sense, but doing 5,000 meters cubed of earthworks costs more than doing 500 meters cubed. Now, I actually think measuring earthworks quantities is actually quite technical, probably much more technical than I would say doing like concrete formwork or electrical works, where you're just really measuring areas or counting stuff. Earthworks, you have to think a little bit more about the technical side of it. So whether material is compacted, whether material's loose, because these different quantities have different impacts on costs. For example, the quantity you excavate is compacted material. It is compressed. It's been sitting in the ground for ages. It's had cars driving over it, whatever it is. It is much more dense. The quantity that you move from point A to point B, the quantity that you haul, is loose material. So if you take the quantity that you're excavating and you use that to calculate how many truck movements you have, you'll probably be out by 20 or 30%, because you're taking compacted material and then making it loose by digging it out of the ground. And then the volume you're working out what you need to haul is loose material. So the principle here is the same dirt occupies different volumes if it's in different states. So the terminology we would use is bank or in-situ material, which is dirt in the ground, undisturbed, which is what you're actually measuring from the drawings when you're talking about excavation. You've got loose material, which is the same dirt, which is after excavation, has more air in it, so it is taking up more volume in a truck. It'll have more voids in it. Then you've got compacted material. So this is after you place the loose material into the ground, you roll it, you compact it, it becomes more dense. So if we think about this in a diagram, we've got our bank, which is our compacted material, which has much denser particles. We've then got the loose material, which is what goes in the back of a truck, which there is some swelling from when you take the bank to the loose. And then you've got shrinkage, which is when you compact it again and it goes back to compacted material. Now, the thing is, these numbers actually vary a lot. So if you're talking about typical swell from bank to loose, for clay, it might go up by 25 to 40%. For sand, it might go up 10 to 15%. For sandy gravel, it might go up 10 to 20%. For rock, it'll go up 40 to 70%. Because if you think about your big chunks of rock, they take a lot more space. Then you've got shrinkage, which is when you compact it again. Again, you're not really compacting rock, but clay, you might go down 10 to 15%. Sandy gravel might go down 5 to 10%. So even in this example, most of these things you're looking at is the swell is the swell is more than the shrinkage. So the amount you excavate will be the amount you excavate will be smaller than the amount you have to truck, which the amount you have to compact is smaller than the amount you have to truck. But it's all, I'm sort of confusing myself by saying this, but I mean, at the end of the day, it's about thinking about the activity you're doing and what compaction in the soil is and making sure you're using the right quantity. So this table is on the CAT website, and it's just the material density table to help understand all these volumes. So if you look at, so they're using the terms loose and bank. So bank would be in the ground, loose is what is in the back of a truck. Clay, you've got 1,600 kilograms per meter cubed. Bank, you've got 2,020 kilograms per meter cubed. That's because of, again, the swell from when you excavate, it becomes looser, it's less compact, so therefore it weighs less. So they've given a table for all these materials. You can take the ratios between these to get the load factors. And this is the sort of information you'll need when understanding these different volumes at different tasks. All right, so let me give you a quick example. if your design shows 10,000 meters cubed of excavation in clay where there's a 30% swell, your loose volume, what you actually have to truck, is 13,000 meters cubed. It's the quantity you excavated multiplied by the swell factor. If a truck takes 12 meters cubed, if you work out the truckloads on the bank excavation, you would have calculated 833 truck movements. If you have calculated it based on the loose volume, you've worked out 1,083. So there's actually 250 truck movements different, which obviously is going to be a huge cost on a project. Okay, so let's go and do our first quantity. So we've got we'll need to calculate our topsoil removal for the project, which is going to be along the length of the berm. So it's going to be the width of the berm multiplied by the depth. So the width of the berm multiplied by the depth multiplied by the length is going to give us our depth. Now, from this, we don't actually know the width of the berm consistently. We only know the batter, which is a 1 in 4 batter. And then they've given us a long profile, which shows the dashed line is the existing ground level. So current ground level, the top of the berm. So you can see the top of the berm is pretty consistent at around 11.9 feet of elevation, tapers down a bit towards the end. But the height, which if you can think of as the height as the difference between existing ground level, the top of the berm and existing ground level. So what we would have to calculate, basically at each of these points, which is useful, they've given us this table, the cross sections, we can work out, basically, let me get a pen, we can work out this height. Well, I assume they're giving it the center, so they're giving us this height. If we know that the dimension is 10 foot, we could then work out, based on this 1 in 4 batter, what this length is. Now, the obviously assumption here, we're not going to capture things like the difference between that height and that height, but it's going to be good enough for what we're trying to do, and we'd probably add a little bit of contingency to it. So basically, to calculate this width, so we know where am I going to write? We know the depth. I mean, this probably doesn't look like the most professional way to do it, is going to be 2 feet. The height we get from this table, which is this. And then if we're using 1 in 4, it means for every one we go up, we go 4 across. So it's going to be the height, the width. I really shouldn't have started writing like this. It looks so unprofessional. Whatever. Height times 4 times 2 plus 10 feet. Now, obviously, if you have CAD and 3D modeling software, it's going to give you better quantities than this, but this is just how you have to think about it. Okay, aside from realizing I shouldn't be doing document, aside from realizing I shouldn't be writing things by hand, I'm just going to extract this table into Word, where I go document, where is it? Tools, file, export, Excel page reason. I'll just export this to Excel. Do that. Get my Excel file, and then I just kept this formula that the width is going to be, what was the formula I wrote, if I can still read it? So no, I'll do it in imperial because it's already in imperial. 2, so depth is 2 feet. Do that. Depth is 2 feet. The width is going to be the height. It's height times 4 times 2 plus 10. So that's the height in feet. So we need, so I get the width. These are the stations. This is the wall height. Then we're just going to go equals times 4 because it's 1 and 4 batter times 2 plus 10. Does that make sense to everyone? Let me know if it doesn't. That makes sense to me. So that is the width. And then we need to know the distance between all these change markers, and we'll just apply the this width between those. Again, it's not exact. It's going to be a bit of a rough estimate, but it should be pretty accurate. So just to see if this makes sense, you can see when the batter is higher, it's much wider. That makes sense because you've got a 1 in 4 batter. So if the batter is super high, it's going to be super wide. Now, it's given us all these lengths in terms of chainages, but and the station numbers, but I don't know how to read feet. So I'm assuming, what is 9 plus 00? I'm gonna I have to look this up before I work out how to calculate the length. Okay, so it turns out I was massively overcomplicating this. So that is 12 feet. That represents 100 feet. So what's the entire length of the berm? Entire length. Oh, so then 3 plus 97 is 397 feet. Okay. I'm just not familiar with that notation, but I had to look it up. Okay, so this makes more sense. The entire length of the berm is 5,037 feet. I just haven't really seen change markers written like that, and it confused me. And everything in feet's just, I don't know. I just find it really confusing. So we know that is 397, 703, 44, 1586, 1962, 24, 24, 3996, 3362. And I'm 100% sure you could do this with a formula. So don't make fun of me. Okay, so they're the changes. And then now we're getting, this formula is going to be should put this here because that makes more sense. This formula is then going to be the width multiplied by, should be the delta between these two. So it should be that minus equals that delta, because you're only applying that width to that area. And if I sum these, there's a typo. So what's the sum of that? 5,037, correct. So that's the total length. So I go width times the delta, and it gives me square feet. So total square feet is going to be the sum of this. And then we know our depth was 2 feet. So our volume, so total clearing grubbing volume is that times that. So that is in cubic feet. And then Mr. Google told me this is that's the conversion factor. And then the volume in meters cubed is that times that. So 10,000 meters cubed is the clearing grubbing, is the volume of topsoil removal. I actually wrote that in meters. So what is that? That should be, close that, 9,601 meters cubed. Now, this probably wasn't the smartest way to do it, because that should be topsoil. Often you get charged a higher rates for the green removal, the grass at the top, so I probably should also include that as a quantity. Also realized the way I've structured this pricing schedule is a little bit confusing. I think that should probably go on to berm construction because that is just for removal for the berm. I'll call that 4.1 and rename that. Call that 4.1. I'll rename that excavation for berm. Rename that 4.2 placement and compaction. Then I'm going to add a new item 2.1, which I'm going to call, I'll give it a meter squared quantity, and I'll call it topsoil / green waste removal, which is removal of that top layer of grass. So if that makes sense, that's, I think, a better way to structure it. And I think you'll find this a lot when estimating, that you set up your pricing schedule, and then as you're going through looking at the drawings, you realize what you've done doesn't make sense. I'm not sure other people probably picked this up as I was doing it. But so now I've got a meter squared rate for removal of all this topsoil for both areas. I've got the tree removal. I've got the excavation for the sediment basin. I've got the excavation for the berm. Then the compaction and surface treatment for both the sediment basin, which isn't really going to be a big placement of fill, and then placement of fill and compaction for the berm. Okay, so now I have got some logic to these quantities. Let's get the rest of these quantities into Excel. So what else do we need? We need area of berm. So to calculate this green waste removal, and there's obviously better ways to set this out. This is a bit random the way I'm doing it. Obviously, if you spent 10 minutes thinking about it, you probably get a better result. Area of sediment basin. So if I want to get the area of the berm, actually we already know this from this because we've got the width and we've got the length. We've got the square feet. So we've got 170,000 square feet in there. That is square feet. And then the area of the sediment basin, which is going to be, let's have a scale on it, 1 to 200. So you got tools, measure, area. Oh no, so tools, measure, set scale. You go, it's preset 1 to 200. And then let's get this total area just quickly. Now this is giving it to me in square meters because everything I do is in metric. So that's, what is that? 502 square meters. So that's 502 meters squared, and I'm just going to convert square feet to meters. And that actually gives me 15,888 meters squared. So total area equals that plus that, 16,000 meters squared, and I'll put that back into, I'll delete the me looking up the conversion factor. I'll hide that. And then that gives us 16,390 meters squared. Tree removal, I'm going to put in an indicative figure. Like, I'm just going to imagine we took photos or had aerial shots and we sent them to a subcontractor and they created a price. So I'm not going to do a takeoff for that. I'm just going to use that as an example. The sediment basin excavation, let's get it. So that's 500 meters squared. We're assuming that is a 1 in 4 batter, and that is going to be excavated to 2 feet deep. So it's 2 feet, 600 mil. So if we assume, so you could actually work out the 1 in 4 batter and get cross sections of these and use the triangle method. I'm just going to be lazy and say volume of sediment basin. So we've got, I'll just break it into the area of slope, and then I'm just going to assume that has an average depth of, say, 100 mil. And then we're going to say the area of the actual basin, we're going to say is 200 mil because that's dug to the design depth. So if I go back to this and we go tools, measure area. So this shape is obviously the sloped area, which is battering down to that design depth of 600 mil. So we'll take that area. What's that? 360. And we know this is that minus that. So then our volume is that times that. So it's going to be 64.4. So excavation for the sediment basin is 60, we'll call it 65. Compaction in the surface treatment, that again, we know that's the same, that's 502 meters squared. Now the placement and fill and compaction of the berm, that is again, we can use this data to calculate that. So what I'm going to do now is I'm going to take, we know the width at the center of the berm was 10 feet. I'm just going to make this super easy and write a conversion in because the imperial and metrics is confusing me. So feet, meters. So the conversion factor is 0.3048. I'm going to make mistakes if I keep trying to do them in both. So I'm just going to convert this whole table into metric. That's 121. So it's the total length of the berm. Oh, sorry, that's change. I have to be careful. I'm doing everything wrong. Which is that times that's 1,535 meters. We know the width in the center was 10. Like if we go back to this cross section drawing the berm, we know the width in the center is always it's always 10 feet. So if we go back, you know the width in the center is always 10 feet. So what is 10 feet? Equals 10 times that. So you know the width is always 3.048 meters. So that means the volume in the middle is always going to be the width by the height. And then if we, then we've got to factor in, I'll just make this a rectangle to be easy. It's going to be the width, the overall width times this area. And then the width times the height gives us that area. And then the width times the batter length times 2, which is the same as making that a rectangle. Which makes me think there's just a way easier way to calculate this. I can take this width and convert it into meters. Which is going to be that distance. Then center volume is going to be this distance times this. Put it in the wrong spot. It's going to be this center distance times this. Central volume. I'll just screenshot this and put it here so my brain can do two things at once. Oh, why'd that go so big? So if you think of that center volume is that area, then we've got the excavation replacement, which is going to be this yellow bit, which is the 200 mil, which is 2 feet, which is 600 mil, times the width times the delta, which is that. Sorry, I just realized I did that wrong again. I need the height, which is that distance. If I go back to this drawing, that is the finished wall elevation, the height in feet. So I just want to get height in meters, which is that number divided by that number. Which, when you actually look at those numbers, it's quite interesting because you can see in the middle around these two changes at the 30 mark, it's almost at the same level as the ground. And then it drops down a lot. So you can see the berm gets quite high. So that's why you're getting this big variability in height. So then, let's do that again. So the center volume is going to be the length, so the delta between the two changes, times the height. So times, why do I keep saying width, height? That red number is the width multiplied by the height. That's the center volume. Then the excavation replacement is 600 mils, which is the depth, multiplied by the delta, multiplied by the width. Is that correct? Width, yes, that is. Now you just have to calculate these two, which is going to be the batter volume, which is going to be, so it's the width of the berm minus this central flat bit minus that central flat bit. So that gives you the width of the berm minus that central flat bit multiplied by the height of the berm. You'd actually have to multiply it by a half because it's a triangle, and then multiply by 2, but just making it a rectangle. Sorry, multiplied by the length. So what does this give us? Totals. Sum that up. 29,000 cube. So let me put that in the pricing schedule. Placement of fill, 29,000 meters cubed. All right, so now we've got our key quantities. We've got the placement of fill and compaction is 29,000 meters cubed. Our excavation, which is 10,000. Got our excavation for the sediment basin, which is 65 meters cubed. We've got our surface treatment for the basin, the topsoil removal. Okay, let's think through the quantities that we've now calculated. We've got our topsoil strip, which again is just an area measurement. The depth probably doesn't matter that much. We'll just assume 50 mil for calculating our grain waste. We've got our bulk excavation, so what's coming out for the sediment basin and berm. We don't really have any detailed excavation, but that would be more things for like trenchings, footings, conduits, stuff like that. We're using a much smaller excavator, so you're not going to get those big productivities as if you had a big machine. We've got rock excavation. Didn't factor any of that in, but if we had certain geotechnical information, we'd have to consider that. Unsuitable material, again, if we had material that we couldn't reuse on site, we'd have to factor that in contaminated material. But fundamentally, we've got the amount of dirt that's coming out, and we've got a quantity that we need to import. When we price this, the big assumption we're going to make that we would have to qualify, or at least get our assumption clarified with the client, is can we reuse all this material? So what we're building this entire batter up from, that compacted fill, we're assuming that's coming from the construction site. Now, when you're doing fill volumes, you would generally have, that would be compacted volume. So the material we've excavated is the bank volume. That's what we've calculated. The volume we're going in, the fill volume, is the compacted volume. Sometimes when you look at cross-section drawings, for example, I've got a good set down here. Like, for example, roads of pavements, you'll have specialist fill or specialist aggregates you need to import. So you can't necessarily you can't assume you're reusing materials. Some of it you will have to import. So sort of structural fill and rock and specialist material, you can't reuse material on site for that. But because this berm is just compacted fill, we're assuming we can reuse material on site as a cost saving measure. We haven't had to break out our quantity takeoffs into structural fill. So the next step is to actually do our cut and fill balance. So what we have calculated, we've got the total cut, how much bank volume is coming out. We've got to then calculate our loose volume, which is going to be truck movements. Then we've got to determine what we're going to reuse and what we're going to dispose of. Okay, so to calculate that, we know that green waste, that's 1639 meters squared. It's not material we're going to be able to reuse on site. So that is stuff we're going to have to take off site and dispose of and pay disposal costs for. So we're really just interested in the sediment basin volume and the berm excavation volume. So we got the total cut volume of this plus this. And then this is bank. This is going to be total cut loose. Let's just assume we have a 15% swell factor. So this is going to be the number we use for truck movements. And then we've got a fill volume, which is a compacted volume. So then to work out what this number is as reuse from cut, we can take this and times it by 0.9, assuming we get 10% compaction. Put that here. So then we know our import volume, import fill volume is going to be this minus this. So we're going to have to import 20,000 cubes of dirt. And like this actually makes intuitive sense when you look at a drawing like this. You would expect for this project that we have to import a lot of dirt. That is only 2 feet deep. It's incredibly shallow. We're only digging 2 feet for the actual excavation for this. And anyway, that 2 feet has to go back in to get compacted. And then this is going up to what? Sort of 4 feet high, 3 feet high, 7 feet high at the end. So it's actually getting quite high, the actual wall. So if we look at this, you can see it's getting up to over 1 meter, 2 meters high. So we would expect to have to import quite a bit of excavated material. So our imported fill volume is 20,000. We've taken a delta between our cut and our fill. Now, in addition to actually working out that we have to pay X dollars per meter cube to import it, we're also going to get a different productivity for that import fill volume. Because if we're just taking dirt from here, to here, that's obviously way more economical. It's much cheaper than bringing in dirt from another site or another quarry. So when we're actually importing fill, we're going to have lower productivities as well. So we've got the cost of importing the fill and also the productivities around it. All right, for being comprehensive and making sure we talk about everything, I'll just fly through a couple other types of quantities you would have to measure to price a complete civil job, including drainage, detailed excavation. So number one would be pipes and any drainage works. It's pretty easy. You just get the actual lineal meters, the number of pits, and then you just find some trenching cross-section like this. Again, trenching, you're not going to have anything near the same productivities as you get with things like bulk earthworks and things like that. So really, all these takeouts you want to track as separate activities. Plus, you'd also have to factor in any pipe laying and stuff like that. Again, you also want to count the number of pits because pits are often messy and complicated and much slower than general excavation and material placement. The other things you want to measure are things like culverts, subsoil drains, pavement areas. Again, pavements can be expensive, more so because of the actual material that goes into them. So stuff like improved subbase, placement of fill, you can reuse a lot of the material on site. But if you're talking about building a road and placing structural fill, asphalt, things like that, you need to really calculate those quantities again, because maybe the placement will have a similar productivity, but the actual cost of the materials will be significantly more. Again, asphalt tends to be a separate specialist contractor, again, which is more expensive. So to calculate those sort of pavement areas, you just calculate square meters looking at a drawing like this. And then on top of that, you look at the cross section of the different pavement types. Usually the pavement plans will mark out all the different pavement types. They'll have some sort of color code or representation. Then you just find the cross section to get the depths, apply the square meters to the depths, the same way we calculated the green waste. And the rest of the quantities you'd be measuring, geosynthetics, fencing, erosion control, they're all relatively common sense. A few ones that can catch you out, which you would typically just derive from your primary measurements anyway, would be things like compaction tests. Compaction tests can be quite expensive, so you'd want to do that. You have to work out the test frequency, and you simply divide the fill volume by the test frequency. Any material compliance specs would be depending on the volume of material you're getting, the volume of the material you're importing, and things like temporary works, which would be the depths of any excavations you're doing. The key principle whenever you're doing quantity takeoffs, really, you break your takeoffs down by all the different types of materials you need and all the different productivities rates that apply. The reason you do that is because all these different items have a separate cost associated with them. So that is the granularity you need to break your takeoffs down by the different materials and by the different production and install activities. Okay, once you've got all your quantities, and again, this was simplistic, but it did take me quite a while. Like doing quantities accurately is probably going to be the slowest part. Is then you need to get your resource library together. So these are all your labor, plant, materials, subcontract rates, your productivity rates, any subcontractor pricing you have. Now, this is just a sample resource library. It's really, the principles are the exact same no matter whether you're using Excel or an estimating software. Pricing is just basically getting a set of all your different cost items and applying quantities and productivity rates to it. So for example, I've got a rate for a plant operator, which is $71 an hour. A truck driver, $65 an hour. I've got a rate for imported fill, which is $28 per meter cubed. And then I've got a rate for imported fill that includes the supply and haulage. I've got rates for things like a water cart, a roller, survey equipment, productivity rates for different activities, and some subcontractor rates if that's the way we want to go. All right, so the first thing I would do is I would start with my direct costs, and then I just work through the projects sequentially. So the first thing we've got is our topsoil and green waste removal. So first thing we have to do is work out what is the crew composition that's going to be doing that. And we're probably going to have something like a 20. If you think about that, let's actually write that down here. So crew composition will be, say, 20-ton excavator. The reason I like having my assumptions and calculations in the same sheet as my pricing workbook is when it comes to someone else actually looking at what we're doing, they can instantly open this and see what we're doing. So we got a 20-ton excavator. We need an operator, a spotter, and we need a tandem to remove the waste, and we need disposal. So what do we say the volume was? The volume was 1639 meters squared. So total area 1639 meters squared. Let's assume depth is 50 millimeters. So volume is going to be that times that divided by 1,000. Oof, that's a lot. And then did we get... So let's just... So our productivity... So productivity rates, like you can... Like the way I would get all these productivities, I'm just going to mention this here because I'm just going to use example productivities in this video. And it's a question I get a lot that... like productivity is so variable. It's so dependent on different jobs. There's so many different factors that impact you. I can give you productivities, but they probably won't apply for your job. So my number one rule is go to someone who knows the work, sit down with them, go through the drawings, and come up with reasonable productivity rates. It's not that hard. You just have to speak to someone who actually knows what they're doing and give them all the information that's relevant to the task. So the productivity rate, let's just call this light clearing. That is 1,800 meters squared per day, which gives us, what's our total quantity? Our total quantity is 16,930. Total area. And I'm going to get these to, as a future update I'm doing, I'm getting these quantities to automatically come into the pricing schedule, so this is easier. So let's go task duration is then just the $9.4 days to 9.4 days. Actually, I should write that in units, shouldn't I? Not in the comments. Actually, and if you want to round up, so you're not missing that extra day, just +1. One comment I will make is I like to have my productivities in the resource library so that as I'm actually doing my pricing, say we're using that same productivity rate of light clearing across multiple tasks, I'll actually go and you can update it in one spot. It's not really applicable to this productivity rate because the only spot we're using it is in this activity. But say, for example, you were pricing formwork and you had 10 structures on a project, you could just have one production rate from formwork that you go and change everywhere. That's why I like having all my variables in a resource library. So the task duration is 10 days. I'll just assemble our other thing I want to add as well is that I'm gonna have in here a complex resource function as well, which is one of the features we've got coming up where you'll be able to actually create bundled rates. So for example, if you want a crew rate for an excavator, a laborer, and a spotter, rather than having to add all three resources individually, you can, actually, I've missed one. So you need operator, spotter, you need a tandem, you need a truck, so you need a driver, and you need a truck, which I actually don't have as a resource. So I'll just quickly just save that. And then I'll just add a truck, which I'm just going to say is an hour. Let's just say it's $40 an hour, including fuel and maintenance. So just add that plant. So we're going to be able to have complex resources where you can actually create an hourly rate for a crew that consists of all these different variables. So you just be able to create like a clearing and grubbing crew, which is going to be way better for pricing. So then I'm just assuming a 10-hour day times the number of days, and then that gives you how many hours you need it for. And I'll just make all these equal each other. And that is going to cover the cost of doing all the removals. The final thing I have to add is the disposal costs. So vegetation disposals, $25 a meter cubed. What do we work out the number of cubes are? 819 meters cubed, which is $20,000. That is giving us a cost for this activity of $63,000. And then when we look at our overall, that's about $4 per meter squared, which, I don't know, does that make sense to you? It makes sense to me. Now, tree removal, I'm going to cheat. I'm going to imagine we took a subcontractor out for a walk, and then we've just got the subcontract rate for a lump sum for tree removal. Let's just say they've quoted us $14,560. lump sum amount, including disposal. And then I'll just add that. That's our lump sum amounts. There you go. So that's the tree removal. No, but excavation for the sediment basin. Now, if you're pricing the same thing over and over again, for example, I'm pricing excavation twice, what I would do is you can create a simple template to do this so that you import the same template. So I don't actually have a excavation template, but you could do it like that. But anyway, let's work this out ourselves. So excavation volume is 65 meters cubed. What other, do we have a productivity? Have I put a productivity in here? Bulk excavation is 60 meters cubed an hour. Oh, so it's only like an hours of work, but we would have to factor in, I mean, to be honest, if it's only 60 meters cubed an hour, we probably should have just had one bulk excavation for the whole project. But whatever. Let's work this out. So excavation crew is going to be, so productivity bulk excavation. Let's make this quantity excavation, and that's 65. Quantity excavation is 65, and we've got our, what's our crew going to be? We're going to have an excavator. We're going to have a truck. Now, when you actually talk about, so this is where civil estimating becomes a bit more of a logistics exercise, and I should talk about an important point here. If this productivity rate of 60 meters cubed an hour is an excavator working continuously, we have to think about how many trucks are you going to need to keep that excavator working continuously. If you're excavating and reusing on site, and all it's doing is, say you excavate here, you drive, you dump, you drive back, you might get away with 2 trucks. If you have to drive to a tip that's 5 kilometers away and it takes an hour, you might have to have 4 or 5 trucks to keep that excavator working. So you have to really think about what the balance of trucks and excavators. I can't tell you what that is. Again, this is where you have to talk to people who actually understand civil construction in a lot of detail. So I'm going to say crew composition, excavator. Let's assume you need 2 trucks, which means you need, for labor, you need a spotter, 1 operator, and 2 truck drivers. Plant truck. All right. Now, I'm also assuming that, again, this is where you really have to think about the logistics, because this is where civil can get really quite complicated. That, say you've already dug, let me do another example. Say you've excavated here to here. Oh, no, actually, it depends where your access to site is. Is your access to site is here, you'd probably start excavating here, stockpiling, and then you begin to build up a stockpile in this area. You could potentially, or say you start excavating here and you have a stockpile from the sediment basin, you begin excavating here, you do all the ground prep works, you could actually start placing material as you go through and do the excavation if for whatever reason you're limited in your stockpile size. So what the benefit of this would be is, say you excavate, this is probably explaining this in a really complicated way. Say you've excavated that, and this section, these couple of 100 meters, are ready to start placing material. You could start excavating here, and the trucks could go and directly place it here, in which case you're not actually double handling. Because if you think about excavating, placing it in a stockpile, coming back later, you would need an excavator here to load the trucks. You'd have to drive the trucks and tip off, and you need another excavator here. If you just excavate this portion and then dump it here, you're actually saving on a second excavator on the stockpile. You're not double handling and reloading materials. So again, this is why, particularly with civil works, you really have to think about the logistics of how you're going to build it, the site constraints, where trucks are going, because you can save a lot of money by optimizing this. But in the interest of not making this become like a 5-hour video of me just talking about different angles, I'm just going to make this really simple. I'm just going to assume we're excavating and placing. So we're going excavator, labor, crew, spotter. I'll go plant operator, spotter, a truck driver, but we're going to need 2 trucks. So we're going to need 1 excavator. So if I just say duration, again, this is not the best example because it's such a small amount. We've got our quantity divided by our productivity, 1.08. I'm just going to plus 1 to make it round up. And we've got 2 hours of an excavator, but we need 2 trucks. So we need this times 2. Should make that duration. Hours. Just save these. We've got our plant operator, which is how many plant operators? We need 1. We need 1 laborer, and we need 2 truck drivers. So it's only 65 cube. That probably makes sense. So that's the cost of just basically excavating this and stockpiling it here. All right, next up, let's do the compaction and surface treatment. So this is going to be really easy for the basin. We're just going to assume it is compaction with a roller, which is 600 meters squared an hour. It is only 500 meters squared. meters squared. So all we're going to need is a laborer, so plant operator, and actually no, we'll make that a laborer, and plant roller, and this is, and let's just make task duration (500 meters squared divided by the productivity plus 1 to round up), and so it's 2 hours of a laborer, 2 hours of a roller. Again, that's not a massive, it's not the biggest cost in the world. Then we take the excavation. So what do we got next? We got sediment basin, which is really wasn't much in it, was there? All right, next up, let's do the excavation for the berm. So I'm just going to use the exact same approach as I did the other one. So I'll just fly through and do it, but it's really going to be the same, just a bigger quantity. So if I take our quantity of 9,681, gives us at 60 meters cubed per hour, divide by that by the productivity rate, gives us 160 hours, which is like 4 weeks. And what's that? We need an excavator. We need a truck. We need, to say, the excavator operator. We're going to have 2 truck drivers. And let's just say a spotter, which is that. And then all we're going to do is take it to a stockpile and dump it. So 160 excavator hours And it's going to be that times 2 truck hours. Truck drivers, that times 2 because we got 2 trucks, don't we? Got 2 trucks, and then we got 2 laborers. That's, again, this is just, that is just taking all this and putting it here, which in practice probably isn't how you do it. You'd be a bit more smart with the methodology, but I'm just mindful of how long this video is getting. Now, something I'm going to do here is, I was just thinking about this. I'm going to break this out to, this is going to be placement of imported fill. I'm just going to break this out into 2 tasks because we've obviously got that first 9,680. Actually, what was our plant balance? We're going to import 20,000. So I'm just going to put these quantities in here. Placement of fill in compaction. I want a placement of fill of reused. Stuff like this, I think, is really important to have in the client pricing schedule because it really articulates your it really helps articulate your assumptions, which I think is like a very important part of not so much estimating, but more contract management. So it's like really clear that the assumption based on this price and what your price is based on is this assumption that you're reusing 9,000 meters cubed of fill. So to do this, you're going to need 2 excavators because you're going to have 1 excavator on the stockpile loading the trucks. We're going to have 2 trucks. And do I have a productivity in there? Grubbing, bulk excavation. No, I don't have a productivity in there yet, do I? All right. Okay, so the crew is going to be 2 excavators, 1 on the stockpile, 1 actually place and fill. We've got 3 trucks. We're going to have a bulldozer and we're going to have a roller to compact it. And the productivity we're going to assume. No, I'm not going to change that. I'm going to add a new one. Placement of fill, and it's going to be a productivity rate. Meters cubed, it's going to be 80. Bulk placement of fill. Alrighty, so 2 trucks, 3 trucks, 1 roller, 1 dozer. Alright, let's price this up. So I have to just change that. So what's our total duration? So quantity 8,9 is 8,990 meters cubed. Our duration is going to be, so this is going to be in hours. It's that quantity divided by that. So it's going to be 112 hours, not meters cubed. And then we just have to go and put in all our resources. So excavator, dozer, roller, trucks. Let's add a few more rows for the labor. Then we got you can see like this is a little bit time consuming. That's why the next feature we're adding is these composite rates, because it's really like it makes stuff like this much faster. Laborer. All right, so is that correct? No, I need truck. Oh no, truck drivers there. Okay, so that, because we've got 2 excavators, it's the number of hours times 2. We've got 1 dozer, so it's the number of hours times 1. We've got 1 roller, so it's the number of hours. We've got 3 trucks, so it's the number of trucks times 3. We've got 2 plant operators, 3, 1 for the dozer, we got 3 truck drivers. And then we've got 1 spotter. Yes, that's correct. And that is just labor and plant, because remember, we're reusing the material on site, so we don't have to factor in the cost of the material. Okay, continuing on, let's do the placement of imported fill. Now, I'm going to make this a bit simpler. We're just going to have 1 excavator, 1 dozer, and we're going to pay a delivery. We're going to pay it for the material plus delivery. So we got 1 excavator, 1 dozer, 1 roller, and we're just going to get trucks coming in. So quantity. So if you think about that, we don't actually have to price any trucks, because in that, the rate we get for this, we're factoring in the haulage from the tip. So if I go to materials, imported fill delivered is going to be $45 a meters cubed, which is going to be 900 gram, which you can, I mean, maybe that's an expensive rate. Maybe it's not. Like, that is actually, importing material is quite expensive. So you could pay for your own trucks and maybe bring it down a lot, but I can't be bothered pricing that. So I'm going to be lazy. So then I'm just doing, what am I doing? Excavator, roller, dozer, operator. The excavator, operator of the dozer. Let's save that. So we use that same productivity, placement of fill. And then you just need to add shall delete that. Let's go. I'm just going to change that to a custom item and make that duration, which is the total quantity divided by our productivity rate. So 251 hours. Then I'm just going to make this our excavator. Make that our excavator operator. We don't have to factor in any truck drivers, because that imported fill, but I'll just fix up that. That 251 hours is the duration of the task. We've got our dozer, excavator, dozer operator, excavator operator. 251 times. No, sorry, this is confusing things. So that is just 251. It's 1 of each. Gonna put in the roller. And then we're gonna put in the laborer for the roller. So save all that, and then you can see that's $1 million for all that imported fill, because it's materials can be quite expensive. Just save these, and then I'll go back, and then there we go. We've priced all our direct costs. We haven't priced project management and overheads. Now, I've mentioned this before, but to me, it is fundamental that you always include this line item, project management overheads, as a duration in your pricing schedule. The reason that is because if there's changed the duration of the project during execution, you can claim an extension of time. Again, to work out this 12 weeks, what I would do is I would look at all the individual tasks. I'd just map them out as a schedule. So you got clearing and grubbing. Maybe you've got placement of said excavation. I'm just going to assume you're doing them concurrently. You got berm, excavation, placement of fill, reuse, and placement of fill imported. And then let's just go to each of them and let's just check. So clearing and grubbing, we had Clearing and grubbing, what was the duration of that task we calculated? We said 10 days. So let's go enter all these in. So 10 days for clearing and grubbing. The tree removal we'll just assume occurs concurrently. The sediment basin excavation was only an hour, so we'll just ignore that. This main excavation was 160 hours, so what's that, 4 weeks? Placement of the reused fill was 112 hours, so we got 160 plus 112, and then we got the placement of imported fill was 250. So I'm just gonna, if you're smart, you'd probably be noting these down, but it was, what was that? 110 hours, 160 hours, 250 hours, and I wrote this in days, but that was 10 days. So then 110 hours is about 15 working days. Again, this is a tender, so it's not like you can be super precise with this stuff, but I find you're just better off slightly overestimating, because like if you're too precise, you just get stuff wrong. So 20 days, placement of imported fill was 250 hours is what? 25 days. So then working days, I'm just going to sum these. Then I'd include mob slash demob. I'd include 10 days. Then I'll include, what's that, 80 days. So total duration net is 80 days, which is, what's that in weeks? That is 5 working days in a week. So what's 80 divided by 16 weeks plus, what's that, 16 weeks. So plus a week of inclement weather / risk. No, it's to say 2 weeks. So 10 days. So the duration is going to be 18 weeks. So that is what we have to allow for our overheads and management. So let's go duration 18 weeks. Then you have to decide on your overhead structure. So we say, let's just say we have an engineer. No, let's just say you have a supervisor for 40 hours a week. To be 18 times 40. Then you need, let's just say you've got an engineer / quantity surveyor. So let's go engineer type overheads hour. Let's just say week. And they're costing us $2,200 a week. So I've just got that in weeks. And then I'll put in a plug number. The thing with overheads that I think is hard is you have to actually think of everything you need. It's not like other construction items where they're just shown on the drawing, so they're easy to calculate. You actually have to think through and work out everything you need. Type overheads, duration weeks. Let's just say for all the toilets, offices, you're getting $1,850 a week. And I'll put that as 18 weeks. And then you can see our overhead cost is 138 grand, which makes sense. It's about 10% of your direct cost. But now we've got a rate in the contract of $11,500 per week, which we can show our client if they're, I should actually update that to 18 weeks. Of $7,960 a week, which is what we can show our client is our overhead costs if they delay us. Then mobilize and demobilization, that's floating all the equipment to site, getting the offices set up. So typically I would say maybe 2 weeks of a laborer's time. I probably missed some stuff in the overhead, so I don't use that as an exact checklist. Like, for example, I didn't have utes or like any utility costs or anything like that. Again, that was just a really quick example. I just probably might put in a float. Let's call that plant cost each, and we'll make that 2,500. No, we'll make that 1,200 per machine. So what do we have? 2 excavators, a dozer, and a roller. So let's calculate that plant. I think we had 2 excavators, a roller, so each way that's 8 plant charges, and then let's just say how many guys we're gonna have. We're gonna have probably max would have 10 people on site, so we've got to factor in. So this has been my induction allowance, which is going to be 10 guys times 4 hours. So 40 hours for inductions. Surveyor for initial setup. You can either do that as a direct cost. So let's just say, no, I'll make that 20. So we'll also include some of the actual construction time in that, 20 days. And then I should add an actual, that's just the resource. I should add an actual surveyor. Surveyor type. Oh no, that's probably more of a subcontract cost. Let's call it an hour. Let's say he's charging us 180 an hour. And then surveyor equals 80. There we go. And there we have our costs to do the work and our mobilization, demobilization fee, risk and bank guarantees. You can do 5%. You can look at the total labor hours and take a percentage of the labor hours for inclement weather. I'm just going to put my markups on that. 2% for risk, 2% for corporate overheads, and there we go. I've got my sell price. Again, these are just, I made up all these resources and productivities rates. You'll have to check them yourselves. But yeah, that's the basics. It's actually not very hard. It's just really thinking through the logistics. So like all the rates I used, you would have to go and get quotes for materials. For the big stuff, you should be getting quotes for every single job. The other important thing to understand about materials is the material costs you get will be impacted will impact the productivities you get as well. So you have to pay attention to, for example, when I priced the materials getting delivered to site, I included delivery in the material cost. So we didn't have to allow for extra trucks. So the core principle with materials is to work out what's included in the material rate and also to allow for reasonable wastage. Labor and plant rates, they're really easy. Plant, you just get rates from subcontractors. Labor, you have to build up to determine your internal labor cost calculations. And the final step is you just take this price and you bundle it into a detailed letter of offer with all your inclusions, exclusions, and assumptions. So the big assumption when we did that tender was we were planning to reuse material on site. It would be essential. So I made sure that was crystal clear in my actual pricing schedule that I've allowed to import fill. That is how we've estimated the cost, but that should also be in your letter of offer and detailed exclusions. You can then simply export this, take your pricing schedule and present it to your client. I hope I didn't ramble on too long. I don't know, I like these more conversational videos where you go through it slowly and I show you my actual working and thinking. It's hard to really plan out a video like this because you sort of organically come across these issues you go across. I hope it wasn't too rambly. I hope you found it valuable. But yeah, if you try out the software, the thing I really want to add is those composite rates because that will make this way easier. And that is a planned feature we have soon. If you've got any other tips, feedback, anything you'd like to see, again, it's completely free to try out. So would love your feedback.